Do you hear that? That, my friends, is a sound of spring that the naturalists at Dodge are so excited to be hearing. That's right, it's sap dripping into one of our collection buckets. All trees have sap, but maples are one of the few trees that have sugar in it that we're able to then cook that sap and make delicious syrup from it. So what's the function of having the sugar in the sap that other trees don't have? All has to do with the structures inside the tree that help the tree deal with the freezing and thawing that it'll go through over the seasons. Let's magnify the inside of the tree. Now, don't get freaked out by all of these different names, but there's the big openings. Those are called vessels. And then there's thousands of these super tiny little openings. Some are called fiber cells, some are called tracheids, and some are called parenchyma cells. The vessels and tracheids are filled with the sap. The fiber cells, they're filled with gases at first. Now, as the temperature starts to drop and freezing starts to happen, the fiber cells are going to be what freeze first. And the freezing happens out at the very tips of the branches first, where it's thinnest, that's going to freeze first. So the twigs, then the branches, then finally into the trunk area and the roots. The sap has the sugar dissolved in the water. The gas inside that fiber cell contracts with the cold temperature. That actually draws water into the fiber cell, and then that water, of course, expands as it freezes. The sugar molecules don't get pulled into the fiber cells because they're too big to pass through the barrier that exists between the vessel and the fiber cells. And so the sugar remains in the vessel. The liquid in the vessels will freeze as well, but it freezes at a different temperature because it's a different concentration than what's in the fiber cells. When the temperatures get above 32 degrees, all of that frozen sap starts to thaw, first in the twigs, then in the branches, eventually down into the trunk. When that thawing starts to take place, the gases that were in those fiber cells want to expand. But because of all the water that's in the cell, there isn't enough room. A bubble forms, and this puts pressure on the water. The water that is in the fiber cells, remember, that was mixed with the gas. The water that's in the vessels, that's super rich with sugar. And so there's an imbalance, and the water from the fiber cells wants to move back into the vessels to help balance out, makes things equal between them. The bubble that's in the fiber cell helps push the water back into the sugary vessel. You don't want air bubbles in your vessels or your tracheids because that prevents the liquid from moving back and forth. And if the liquid can't move back and forth, then the tree isn't going to be able to leaf out. It's not going to be able to grow. Sugar maples have most of their vessels functioning by the time it's warm enough that the tree can start doing photosynthesis again. Other trees, they've studied this in oaks and ashes, maybe only 15% of the vessels in their wood is actually functioning. So those trees tend to leaf out later in the springtime. The syruping season can be a short one. Once we get to the point of where temperatures stay above freezing at night, we don't get that pressure buildup in the tree to have the sap being pushed out anymore, and the syruping season is over. So now you know quite a bit about the science of sap. It's a lot more involved than I ever realized it was. Thanks to my coworker Mick for giving me a lot of the background information for today's episode of Nature to Go, and we'll talk to you again next time.